While we were discussing the transverse wave, we have discussed that the direction of the particle velocity will always be perpendicular to that of the wave velocity. We have discussed in the beginning classes, first classes or second classes we have discussed. Okay. So you can ask me that what will be in the case of the longitudinal wave? That in case of the longitudinal wave, that means in the case of longitudinal wave, what will happen? That the wave will propagate along the motion of the vibrating particles of the medium. So what will happen in this case? In the case of this longitudinal wave, the direction of the particle velocity, that means this one, is always along or opposite to that of the direction of the wave velocity. That means this one. Clear? So study it accordingly what happens in the case of the transverse wave as well as to the longitudinal wave. Alright, so relationship is more or less done. So let us move to the next one. The differential equation of a progressive wave. So let me rub my board. Alright. Okay. So now we will see what is the differential equation of a progressive wave. Alright. Okay. So as usually, let us consider the displacement of a particle in a progressive wave. The usual equation that we write, that is y equals to a sine within bracket omega t minus kx plus minus phi. Okay. What we will do now? Okay, let me write the topic name, just a minute. Now we will find the differential equation of a progressive wave. I am writing it short. Okay. Writing the equation once again, y equal to a sine within bracket omega t minus kx plus minus phi. Okay. So your y equation is this. So what we will do now, we will differentiate this y twice with respect to t. I hope you all know how to do the differentiation in your maths classes. I hope you have learned. Okay. So del square y by del t square equal to minus omega square a sine within bracket the same thing, that is omega t minus kx plus minus phi. Okay. So what we are doing, we are just differentiating y, the previous equation, with respect to t twice. That's why I've written here del square y by del t square. Alright. So what we will do now, we will do the differentiation. This part is over. Okay. Now what we will do now, we will differentiate y again with respect to x. How many times? Twice. So del square y by del x square equals to, just differentiate this with respect to x twice. What will be the value? Minus k square a sine within bracket omega t minus kx plus minus phi, isn't it? So what we are doing, we are just differentiating this y with respect to x twice. Alright. What we will do now, we will just now divide this part by this part. That means now del square y by del x square by del square y by del t square. Okay. So whatever value we have got from these equations, we will divide it accordingly. And what will come to us? You will be left with k square by omega square, which is equal to 1 by v square, big V1. Okay. Why we are writing? Just recall that previously we have come to this particular formula that as wave velocity, I'm writing velocity as velo, but in your exam you will write full wave velocity. Don't write in short form. As wave velocity v, big V equals to omega by k. Okay. K means your angular wave number. Okay. So in this part what we are doing, we are dividing this two difference, that means del square y by del x square and del square divided by del square y by del t square. We are getting just this value. This is simply mathematical part. Okay. So we are getting the final result as 1 by v square. Okay. So let us rearrange it and let us write again. So del square y by del x square equals to, this will move up, this will move up. Okay, previously you had this 1 by v square into del square y by del x square. Alright, so finally we have come end to this derivation. Okay, so del square y by del x square in your LHS part and all other things, that is 1 by v square. You had it in your previous equation, and just this del square y by del t square, it will just move up. Okay, so this is your final equation. So this is the differential equation of a progressive wave. Alright, you can also mark this equation as number 2 of the final equation. Alright. So students, more or less we have covered all the types of equation of progressive wave. Okay. So now let us move to the next part, that is the reflection of waves. Alright. So students, I hope the reflection of light you have learned in your junior classes, isn't it? The terms I am naming once again, the point of incidence, the point of the reflected ray, the incident ray, I hope